Good afternoon and welcome to Women Build, our basic skills session. Tonight we have framing with Caitie. So I am going to turn it over here to Caitie in just a second. And just a reminder to anyone who's new to these sessions, it's meant to be interactive question and answers. So Caitie will pause now and then so you can ask questions. But if you have a question at any time, feel free to just unmute yourself and shout it out too. And if you don't have a microphone, then feel free to use the chat and I'll relay your questions to Caitie. So I think that's it. Caitie, go ahead and.
Great. Well, yeah, thanks everybody for coming tonight. Like Tracy said, my name is Caitie. I will be leading the workshop here tonight about framing, and I'm glad everybody is here. Framing is one of our more popular topics, so you're in for a treat. So I'm gonna, I kind of have an overview of what I'd like to cover in the workshop, but of course, if you have questions or comments or anything that you want to learn about, feel free to shout it out. Ideally, we would be doing this in person, getting our hands on all the materials, but today I'm just gonna do my best to demonstrate and show some different things and go through some different concepts. So let me know if you guys have any questions, and also if there's any weird technical things going on you can't hear or see or whatever. Otherwise, I'll just jump right in and pause every so often for questions. So to get started with our subject of framing, I'd like to start by going through some of the different materials that we would need for framing. Then I'll go into different components for building a wall, which we're going to do a mini wall today or tonight. And I'll also go over some tools that you would need throughout this process as well. And I'll teach you guys how to do layout. So if you wanted to build a wall in your house or build a shed, something like that, something fairly simple, straightforward, hopefully you can learn that here tonight. And then I'll go through a few other framing concepts. So that's my plan. Stop me if you have questions, okay? So to start, I thought it would be helpful to go through some of the different lumber that we use. And the most important thing is the difference between the nominal name of lumber and then the actual size of lumber. So what I mean by this is the nominal name is basically what we call something. So this is a piece of 2x4. So its nominal name is 2x4. This is a piece of 2x6. And of course, this keeps going up 2x8, 2x10, 2x12. But it's actually smaller than it's called. So if I put my tape measure on here like this, it's actually 1.5 inches by 3.5 inches. Same thing, the 2 on this 2x6 is actually 1.5 inches wide, and it's 5.5, I guess, thick and wide. So when we're talking about different lumbers, you're going to hear it called a 2x4, a 2x6, a 2x whatever, and just knowing that conceptually when we're building our walls that's not the actual size that it is. And that's going to be important, and you'll see later when we get into building our wall. The reason that this is if you can kind of see the corner of my piece of lumber here, it's kind of rounded, it's a little bit smoother. So basically when our lumber now is manufactured, it's sent through mills that kind of down from a 2x actual 2x4 to a 1.5. So if you go into a really old home or you're renovating an older home, you'll see true dimensional lumber that's actually 2 inches wide, 4 inches thick. We've kind of started to cut some corners over the years, pun intended. So those are just a few things to be aware of whenever we are framing stuff. And this does kind of change throughout different sizing. So once we get into like a 2x10 size lumber, instead of a 1/2 inch, it's actually 3/4 of an inch smaller. So it kind of gets complicated, but really the thing to look out for here is this might not be as the exact size that it says it is. So double check that whenever you are ordering lumber or buying lumber for a project. So that's one thing right off the bat to be aware of. I also wanted to talk about, sure about a longer board, that's okay. Sometimes in our lumber, we have defects in the lumber. And so what I mean by this is basically any bends or bows or knots, any kind of deformity that would make the board not totally straight, which is what we ideally want whenever we're framing something. If I'm putting these studs in a wall, putting a roof on it or a floor on it, I don't want something that's like bent like this in the middle. So make sure that whenever you're picking out lumber, especially in like Lowe's or Home Depot, that you're checking for any kind of things going on in the board. So I thought it was in here too. I forgot I also have a smaller piece of lumber, which this is more for like a finished kind of material. This is not a framing lumber, but the same concepts apply. So this is 1.5 by, I think this is 3/4, and this is called a 1x2. So when you're looking at the label, it says 1x2. It's actually smaller than that. Kind of the theme. Okay. The other thing I wanted to go over the differences between is OSB versus plywood. So basically both of these pieces of material are called sheathing, and the table that I'm on right now is OSB, and these boards are basically what goes on the outside of a wall, and we'll get to that. That'll be one of the things we do at the end tonight. And this is an important material because just flip the on-off switch on it. Sorry, our compressor's running. Might be hard to hear. Sweet, that's better. So both of these materials are added onto a wall to help tie in together each of the individual studs inside the wall. And what this does is give it what's called shear strength. So basically strength going this way, right? So if my studs are running vertically, it helps tie everything together so it doesn't just blow over, basically. So both of these are essentially the same function, but they are look a little bit different and have some slightly different applications. So we'll do the plywood first, which basically it's a lot smoother, a lot finer of a grain. And if we look at the side of it here, we can see that lots of different layers. So this plywood is basically made by big long sheets of wood that are glued and compressed together. So that's how it's formed. And the use for this would be basically in a section where maybe if we're going to paint the side of it or front of it, or if like let's say we're putting it up in the roof and we're going to be able to see this in our finished roof. This has a nice, much nicer look to it than the plywood or the OSB over here, which you can see is kind of rough. Got lots of different, variation in it. So it's not as smooth, kind of rougher. And this is because these are basically wood chips that are glued and compressed together. So it's a similar process, but different starting point for material. OSB is better for shear strength, which is that kind of side to side movement within a wall. So this is what we would use to sheathe the outside of our walls. And again, we will get to that again later tonight. But you hear those two terms, that's kind of what we're talking about. Yeah, I guess if you wanted to see them side by side, you can't really see the layering in this as much as well as you can here. And obviously the chips versus just kind of a smooth piece of wood here. So I also wanted to go through a couple different kinds of nails, which I guess more broadly are called fasteners. And this is basically what we're going to use to tie stuff together. So I have a few different kinds here, and I'll go through the main takeaways. But so I guess to start off, you can see that, here we go. Here I have a few different sizes of nails. And basically the big takeaway is framing, you're going to be using the bigger nails, right? So if we're putting together something like a wall or a roof or a floor system, I want a big long nail that's going to have a lot of grip into whatever I'm doing. So I'm nailing together a 2x4. This goes all the way through the 2x4 and then sticks into whatever I'm nailing it to a lot. I want that, so it's holding it together. If I use this small nail, I'm just barely getting through my 2x4, that's really gonna cut it. Same thing, gonna step up. I would ideally like to have more nails sticking in here. You can also see that the gauge of these nails is different. So this is gonna give me, it's got a bigger head. It's just got a bit more grab to it. Yeah, the gauge is the thickness, yes. So big nails for framing, these are called 16D, which basically refers to the gauge, as we just said, and then also the length. And then this smaller nail is what I would use for my shing, which in this case is the OSB table. I'm only going through, you know, they do come in different lengths, but I'm only going through a 1/2 inch to 3/4, maybe an inch. So I still have a ton of grab that would be going into my 2x4 wall, which is perfect. On the tops of these nails, I don't know if you can see it, but it does have a little waffle pattern. And this basically matches a waffle pattern that is on a framing hammer, which I will grab right here. So this framing hammer, you can see it's also got this kind of waffle grid pattern. And this is to help give it some grip. So when I'm nailing this in, it's not as slippery on this surface. It's got a little bit of grip. If you miss, it's still gonna hurt your finger though, just to clarify. And then one other thing that I wanted to point out is if we go back to looking at these two nails, we can kind of see that they look a little bit different. So basically, this nail is called galvanized. So this is dipped into something that makes it rust resistant. So this would be something I would use on an exterior, meaning an exterior that isn't going to be covered or completely dry at some point. And then this is a non-galvanized framing nail. So this, if I'm using nails on a deck board and that deck is just going to sit there, totally exposed, a nail that's not going to rust. If I'm framing a wall.
Caitie, I think you're having a bandwidth issue because it's getting hard to hear you. And it looks like we lost her. Okay, so she has a backup computer there. She was afraid this might happen, so she'll be just a second.
On. Shit. Yeah.
Can you hear us, Caitie?
Hey, yeah, I can hear you.
You're much clearer now. Yeah, I can hear you, but we don't have any video for you.
Okay, I'm gonna get Michaela to pull it up on her computer, and we'll try it from there. Sorry.
Yeah, sorry about this, everybody. Bear with us here a second.
Give me just a minute, Tracy. Should be getting it pulled up pretty soon here. Let me get my, okay.
Thank you,
got it up
Joseph.
there.
Joseph says, no worries, great job so far. So yeah, it's a year into the virtual world. Do you think these things would get easier? Okay, Caitie, I see you.
Can you hear me?
And I can hear you. There you
Okay,
go.
well, we'll keep trying to roll with this. Be a little bit different on the computer here, but that's okay. All right, so I'm not sure exactly when I cut out, but yeah, I think I was talking about galvanized and our regular nails here. So the galvanized that are coated would be for like a deck that's going to remain exposed to the elements. And then my non-galvanized I can use in, let's say, wall framing, even though my wall might temporarily be exposed to water. Eventually, I know that I'm going to put sheathing on it. I'll probably put siding on it, and I'll put a roof on it. So this is going to be completely covered, which means a little rain for a couple days is not going to hurt it. But I wouldn't want it exposed for long periods of time, right? So any questions on any of the materials? That was a good amount of the stuff that I wanted to cover in that section. Otherwise, I'm going to keep rolling, but feel free to chat or unmute and ask a question if you have it. So next, I'm going to go into my wall components, which is going to come in handy for when we build a wall in just a couple of minutes. So I'm going to hold up this sheet and kind of talk through it a little bit. But basically, this should show you everything we're going to be doing tonight. So you said, do you want me to push this? Sure. On the bottom here of my wall diagram this is called my bottom plate, and it goes along with up here my top plate. So those are the two 2x4s that we're going to start with to do our layout. And then I have an additional 2x4 cap plate on the top, and that is going to be helpful to tie in all of my walls together. And we'll do a little bit more of a demonstration about this as we build our walls. So then the vertical members that are running up and down in between my top and bottom plate that are the full length of the wall, those are all called studs. So that's our kind of vernacular for all of the pieces of lumber in our wall that aren't anything else. They're called studs, right? And then over here, I have a picture of a door, and over here, a window. So both of these take a little bit extra framing to basically make what's called a rough opening, which is essentially a hole in my wall that is a size that ideally we know ahead of time. So if I know I'm putting a certain size window in here, I'm going to build this opening to fit that window. Same thing for a door. So if you hear rough opening, it's just talking about a hole in the wall that's a specific size. So within both doors and windows, you can see that there's a space within that opening that doesn't have a stud running through it. So basically that means a section of the wall is not supported. And so in order to compensate for that, I need to make a header, which is this thicker board here. This could be a 2x10, a 2x6. It just depends on how big that opening is. And that's something that you can find more specifically in your local building code. But typically a 2x6 to a 2x6, 2x8, or 2x10 are going to be standard header sizes. So this header over both of these, and then in combination with the header goes the jacks, or I think they're also called trimmers on this sheet. That is basically to support the header, and between the header and the jacks, that is going to redistribute that weight in the section of wall where I've created a hole. So that is sufficient to, having another stud in the middle here. Instead, I have two extra supports and a header that's going to redistribute that weight and support the weight. So that needs to happen within a doorway as well as a window. The only additional step in the window is the header creates the top
of my hole. The jacks are the sides of the hole, but then I also need a sill, which is this additional horizontal piece that's going to create the bottom of my hole. So if you hear window sill, that's an easy way to remember that my window is sitting on top of a sill, right? And then the sill kind of acts the same way as a header does. Underneath that, I would also put some jacks or some sill supports in underneath it to help hold that the weight of the window that is going to be in there. So any questions on that? It's kind of a lot of terminology, but we will go through this a few more times tonight when we're doing our layout and then as we build our wall. But I wanted you all to be able to understand some of the terms I'm throwing out there, so it kind of makes a little bit more sense. So if you need a refresher on any of this, let me know. Otherwise, I will keep rolling here. All right. Okay, so now we are going to start doing the wall layout. And in order to do this, I guess I wanted to kind of talk through how we would figure out like what size, what length of everything that we need. So if I'm building a, which I'm building tonight, a 4-foot long wall by 2 foot tall. So in order to do that, starting, I would need my top plate and bottom plate that are 4 feet long. So we're gonna go and cut those. I don't know how well you'll be able to see me on the computer versus the phone, but we'll give it a go here. Okay, so I'm going to be over here cutting a board. So basically, I went to the store and I got 8-foot boards, so 8-foot 2x4s. And when you get an 8-foot 2x4, it should actually be a little bit longer than 8 foot. The reason being, we want to be able to cut 2 4-foot pieces out of that, or maybe we wanted 4 2-foot pieces. So it's usually a little bit longer. So it gives you that wiggle room to cut something. So I've already marked out my 4 foot from each direction. And then I'm going to be using a skill saw to cut this. So I have a battery skill saw here, which I'm not going to get too much into tonight, but we do have tools, workshops, if you want to know more details about this. But you could also use a chop saw to accomplish the same thing. It's just a straight cut for this. So I'm going to go ahead and cut that now. This is going to fall right here. Okay. So now I have both of my top and bottom plate, and we're gonna go do the layout with this now. Okay, so now I have my 2 plates as my top and bottom plate. You can try to set it down and we'll see if we can tilt it onto what I'm doing. Okay, so so I have my top and bottom plate here, and as I'm doing this, I want my sorry, we're trying to figure out how to do this with the computer. I'm going to need you to show the 2x4s that I'm on. Okay, there we go. So I'm going to start my layout by making sure that my boards on the end are completely flush. And then I'm gonna lay out my studs. Basically, there's two different ways you can do this layout. One is 16 inches on center. The other one is 24 inches on center. And basically what that means is every 16 inches or every 24 inches, there will be the center of a stud. So if I'm nailing something or basically it's meant to distribute the weight within the wall. So if I'm doing a exterior wall, I'm going to be doing 16 inches on center. If I were doing an interior non-load bearing wall, I could do 24 inches on center, but tonight we're going to do 16 and pretend this is an exterior wall. So to start that, I have a tape measure here, which is going to be backwards for you all, but you'll get the idea. So I'm not going to go too far into reading a tape measure, but the big things we need to know here are the lines running all the way through my tape like this are full inch lines, which is going to be important. And then if you come down here, you can see that there's a red box right here around the 16. That is to help me when I'm doing layout for a long wall. I know every time I come to a red box, that's 16 inches on center. If we were doing 2 foot, you can see there's a black arrow around this 2 foot. That's going to be every 2 feet if I were to do a 2 foot layout or 24 inch layout on center. So to start this, basically you also need to know that at the very start of a wall where I have or where I have the end of my 2x4s, I need to have a stud here because otherwise this top plate and bottom plate would just be loose and not connected to anything. That's no good. So we have to start with the stud, then we'll keep going our layout all the way down the board. And we are going to keep our tape measure hooked on here the whole time. So I don't want it hanging off. I can't move it here. I need to have it hooked at the front of my board, right? So we know from earlier that our 2x4 is actually 1.5 inches wide. So I know that my first mark is going to be 1.5 inches in, and then I'm going to put an X. An X represents a stud, and I'll show you a little bit more about the layout marks. So I'm going to mark that every time I have a stud in my wall. Then I'm going to take my speed square, which I have here. I'm going to take the edge of my square, bring that flat against my 2x4, square this line so that it's the same on both of these, the top and the bottom plate. So that's why it's important that I'm flush here on the end. And also, you need to do these, the top and bottom plate together versus separately in case, you know, anything gets off. You want your plates to be just matching up exactly. And that way, if you need to make any changes, you just make them, you make the change one time, transfer it onto both boards, and it's consistent the whole way through. So that's my first stud. Then I'm going to go to my 16-inch mark here. And again, we know that my stud is 1.5 inches wide, and I want the center of my 2x4 on here. So if I start it here and go 1.5 inches over, I only have a little bit of my 2x4 on here. So basically what I want to do is go 3/4 ahead or behind, I guess, and then 3/4 ahead so that that equals 1.5 inches overall, right? If I put my tape measure here, I'm at 1.5 inches, which is how wide my stud is. The center of it is on 16. I'm good to go. I'll put an X and keep going to my next stud. So my next one down here, same thing. I find my next red mark, 3/4 behind, 3/4 ahead, X for my stud. And then now I'm at the end of my 4-foot board, and I know that it's going to be just the last 1.5 inches and that it's a stud. So after I've gotten all of those marked out, I'll just transfer those marks with my square, make sure I put all the X's, Easy enough, right? So then once I have all of that laid out and transferred, in this example tonight, I'm going to be doing a rough opening just right inside a stud bay. So instead of creating a size opening that I need, I'm not actually putting a window in this wall, so I'm just going to put my jacks right on the inside of my studs in this case. And so there's also a shortcut on my speed square that basically I can see where my 1.5 line is. So I'm going to use that as a cheat right now. Line up my 1.5 mark. Maybe if you can tell, it's this mark right here. So I'm going to line that up on the line that I just squared through here, make that mark. And now I'm going to put J for jack, or you could put T for trimmer. I've always learned that they're called jacks, so we're going to go with that. So same thing if I were going to be putting in, you know, a door on the same wall later down, I would do the same thing. Find my rough opening, put my jacks within that, and then keep rolling with my wall, right? So any questions on that layout? I know I might have gone through that a little bit quickly, but basically 16 or 24 inches on center, and then making sure that you get that 1.5 inches centered, right? So any questions, feel free to chat or chime in. Otherwise, we're gonna keep going here. Okay, so next we need to figure out how tall to make our studs, right? So if I want my wall to be 2 foot tall, final product, 2 foot tall, I need to account for my top plate, which is 1.5 inches, my bottom plate, which is 1.5 inches, and then my double cap plate, which is that plate or the 2x4 that goes on top of my top plate. So basically that's 3 2x4s that are 1.5 inches. So I need 1.5, 3, 4.5 inches to account for in that wall. So if my wall is 24 inches overall, I need to subtract out that 4.5 inches and I get 19.5. So that number is going to be how tall I make my studs. So that's if you're making, you know, a specific height wall. Like I want this wall to be 2 foot exactly. If you're doing like a standard size wall, like in construction or home building or even a shed, they do make pre-cut studs, which basically means that you can buy, instead of an 8-foot board and they're all a little bit long and all a little bit different, you can buy pre-cut studs, which are already calculated, already at the length you need for an 8-foot wall or a 9-foot wall. So that's really handy to build within kind of semi-standard building codes, which would be an 8 or a 9-foot wall. So for us, we're doing something fancy. So I thought I would go through kind of that thought process to figure out our stud height. Luckily, I've already cut all of those, so you don't have to hear the saw over and over again. But next, we are going to start going through actually assembling a wall. So for that, we'll be back outside. Any questions, please feel free to chime in. Otherwise, we're heading out there. You're on the computer. Okay, so how's our lighting? Pretty good. Okay, so all right, so these are my shorter studs that we've already cut ahead of time that I'll just double check are the same size. 19.5, so I'm good to go. That's my full length stud. So before I start putting this together, I wanted to go through a nail gun safety. So I'm going to use a nail gun because in the past when I've tried to do this workshop, it's really loud and takes me a minute to hammer everything. You could just as easily do this with hand drive nails, which were the ones that we went over inside. So my nail gun nails look like this. They come in a sheath that's basically these little plastic pieces that hold them all together. These are the same size, the framing ones, not the smaller ones. And then this is my nail gun. So, okay, so nail gun safety. This is not plugged in. So if we are ever working with a compressed tool and we need to mess with it or do anything, make sure it's unplugged. So basically up here is the tip of my nail gun. This needs to be compressed, which you can see it slides in and out. Do not do this if you're plugged in, okay? So this slides in and out, and this acts as a safety feature for my nail gun. So when I pull the trigger here, even when I'm plugged in, it doesn't just fire out nails. It has to be compressed, and I have to pull the trigger in order for it to fire a nail. So that is important to know. Also, there's a ton of information right here on this nail gun, which, let's see if I can get it to focus, sort of. So basically right here, it says 21 degrees. Then it has some information about the size of nails to use or that will work within this gun, as well as how much pressure you should have in your compressor. So that is all important to know. You can't use like a 18-degree nail in a 21-degree nail gun because this angle, sorry, slow down. This angle of the nail and the tip is not going to be compatible. So your nails won't fire. We don't want that. I hope these are actually compatible. Okay, so then this other piece here, kind of flipped upside down now, but this piece is the feeder to keep sending my nails through so that they go to the front and fire out. So if I want to take my nails out, I need to push them behind here like this, and it just has a little clip here that will let you release the nails. And then there's an additional one in the back so they don't come out by accident, which is good. So they just slide right here in the back. You see this little slot here. These just slide right here in the back like that. Double check that these are. Oh, good. My nail gun is compatible with the nails that I brought. That's good. Okay, so then to insert my nails, I'm going to go right through this slit like so. Slide them all the way down. And then this does need to come back up and over my nails. Right now, there's nothing actually feeding it. So I'm going to slide this up, gently push it or let it come back down. It's kind of spring loaded, but don't just let it snap. That can wear and tear on your gun. So that's my nail gun that I'm going to use. The other thing I wanted to show you all is the compressor, which is over here. So the way that nail guns and really any kind of pneumatic tool works, pneumatic means that it's air powered. So this is the air that's powering this gun. So in my compressor here, I have two different nozzles, one that's telling me my tank pressure and one that's my regulated pressure. So basically, the tank pressure is what I'm setting it at. So if my nail gun says, which this one is between 80 and 120 PSI, I want to make sure that this is set within that range. So it's compressing enough air that it will fire the nails coming from this gun. And then my regulated pressure is going to tell me what the pressure inside my tank is actually at. So I let this turn on before the workshop. Now my tank pressure has dropped a little bit. So if I were to just leave this on, it would kick up and start refilling with air every time it dropped below the pressure that I set it at. So I'm going to try to leave it off so we can hear each other, but if it gets too low, I would have to turn it back on. So then the other thing that we would need for this, and again, I just thought it would be fun to kind of go through some of this stuff. You can do all of this by hand. It's just as fun. That's the Habitat way. It's even more fun, honestly. So don't feel discouraged if you don't have all of these tools. So basically I have an inside and the side that needs to be pushed into here. So the way these work is this, sorry, slide. Yep, that's good. If I pull this back, then I can insert this in. If I don't pull it back, then it doesn't go. So I'm going to pull this back, push, and then release. It's kind of a quick process, but that's how you do it. And then make sure that you hold on to this this side of the hose, because if you don't, this can just shoot back. So make sure that you're keeping hands on at all times. Okay, and then the other end here is basically the exact opposite. So this connection on my nail gun is the same to my hose. This side is the one that was on the compressor. So this one goes on here. Try to shoot it down a little bit. Same way, I'm gonna pull this back, push in, and then release. So pull, push in, release, and I'm good to go. You'll know right away if this is not on. It'll shoot off or you'll hear a ton of air leaking. So now I know I'm in. I could hear some air come into the gun. That's a good sign. So we'll see how many I can get in before our compressor shoots off. Okay, so let's see, point it down a little bit more. That's good. Okay, so now I have my top and bottom plate here. Can you take like one step back? Okay, perfect. I have my top and bottom plate here that has all my layout marks. And I want to make sure I'm going to separate the two of these so I can put my studs in between it. I have to make sure that I don't twist or turn this around. So if I flip this here, now my marks aren't going to line up. So make sure that this just goes straight back from your top plate like this. Then I'm going to just place all my studs in between before I start nailing them all. Like this. Once I have them lined up, then I'm going to go, maybe you can come in a little bit closer so you can see. Yeah, okay, so now I can see, I'm going to start at the end of my board, and I can see that I have my 1.5 inch mark, but what is more important on this outside one is that I get this lined up. So let's say I was even 1/8 of an inch off, and I go based on my line, I don't want to be sticking out here. So that's going to be my determining factor here, but it looks like my line is spot on. So I'm good to go. I'm going to nail it in with my nail gun. Might be a little loud, so if it's too loud, we can mute me while I shoot it together or something. But I'm going to compress, pull my trigger, and then make sure that you keep your hands here out of the way. So I don't want my fingers right here. I'm going to hold my hand back a little bit, make sure everything's lined up, and then shoot it in. So my compressor is too low and it's not completely sinking my nails. So what I'm going to do is mute myself, turn on my compressor, and keep shooting it in, and you guys can just watch. Okay. Okay, so hopefully everybody could just see that okay. I just got all of my studs shot in, and hopefully you could see as I was going, I was, you know, lining up within those layout marks. Tilt down a little bit. Lining up within those layout marks, and then also making sure that I'm what's called flush or even with the top of my top plate and bottom plate. So all of these are the same size, but what I want to avoid is shooting something in where my board is sticking up like that. I want to make sure I'm nice and even over that. Okay, so then within this window, you tilt down some. Thanks. Okay, so within this, this is going to be my window, which, as I said before, is just going to be within this stud bay. So what I have here is a header, and we don't, we want this header to be going like this orientation. So like this in the wall, not like this. So I don't want it to be in the same orientation as my top and bottom plate like this. I'm going to want it going flat because this is going to be a stronger axis. This is a stronger axis than laying flat. This can easily bow or dip or anything. Up and down has more strength. So my header is going to be going into my wall like this. And basically, if I just had two 2x4s, I know it's an inch and a half. That's only 3 inches. And I need to fill up this entire 3.5 inch top plate. So in order to do that, you can take either a piece of 1/2 inch OSB or also like blue board or foam and fur that out. So I'm not going to nail all these together so I don't have to keep muting myself and we can talk as we go. But basically now this is 3.5 inches. This is what's going to go in the top of my wall, hopefully, if it fits. It does. And I want this all the way at the top. After I get that in, then I'm going to be putting in my jacks or trimmers, which are these shorter boards. These again would just go right underneath my window here. Some windows also, maybe this would be, you know, if my wall was bigger than 2 feet, maybe my header would start down here. In that case, I would also put pieces above my windowsill. So got my jacks in like this. Great. Then I didn't actually determine exactly what size I wanted my window, but I just picked a distance to put my sill at and cut blocks to go underneath it. Those would be the same thing as my jacks or my trimmers, but these ones go under my windowsill. So as long as these are, in this case, since I'm not putting a window here, as long as these are the same all the way across, then when I put my sill down, it would be level or the same height. So that's how I would kind of build this box in. Now, as I'm doing this, my jacks would get nailed in the same way as all my studs did. So would my sill supports, right? Nailed from the bottom. And then these would also get nailed together. So you could do that one of 2 ways. One, either by building the stud jack piece before you put it in place, like nailing it together and then putting it in, or you could put it in how we've done here, and then I would just need to drive nails from both directions into this. Same thing on this side, nails in both directions, then nail my sill jacks in, and then my windowsill just gets nailed in to my sill jacks just like that. So then I would be able to put in my window or my door or whatever in this place here. Any questions on that? Okay. Otherwise, I did want to go through kind of what the cap plate situation would be like, and then show you all how we would put sheathing on to tie this all together. So in order for me to do that, I need to put in, nail in a few more things. So I'm going to mute again and turn my compressor back on, do that whole thing. Any questions? Start thinking of those now as I work. All right, so on this second wall, I only put in 2 because I just want to be able to demonstrate how we tie stuff in together. Let's see. All right. So all my components that I didn't nail in are going to slide right out, which is fine for this purpose. But now I have my 2 walls, which most likely I would be putting together like this. And as you can see, my walls are the same height, which is good. And then when I tie these together, I have 2 of my studs running up and down, and I would be nailing this stud into this one here to help tie those together. And then I would also, to help reinforce this, obviously I have 2 walls joining, and right here there's a break in those walls, which means this is a weak spot. So in order to reinforce that, I'm going to use a additional 2x4, which is going to be my cap plate. And this 2x4 is going to go over across both of these. So I'm going to go all the way flush to this outside edge here, and then I'm going to go even with this 2x4 on this side. I'm going to nail it into this wall, nail it into this wall, and that is going to reinforce the break here. So that's going to happen at every corner. Also, if I were doing, let's say, a really long wall that, turn down here, if I broke a wall, like it's a 30-foot wall and I'm using a 16-foot board and then cutting another board to go the rest of the way, I might have a break in my top plate or my bottom plate. In that case, any break in the wall, I would want to overlap it with my cap plate, meaning this cap plate should never fall just like this, even with another break in the wall. It should always overlap it, or if I had my 2 walls joining together like this, in this scenario, which is kind of the one I was just trying to talk through. they were joining like this, I would never have a cap plate end here, would always have it overlap so that it could tie these two walls together and reinforce that break. So hopefully that sort of makes sense as to why we have the cap plate. It's also going to bring our wall up to that 2-foot height overall. So if I have my cap plate here and I check the overall height of my wall, we can see right here I'm at 2 foot and I'm ending exactly where I want to be, right? And I just want to grab one piece of sheathing, which is my table inside. So I'm going to go and grab that and show you how we would put that onto this wall. And that's sort of my last thing. So any questions, be thinking of those. Okay, so part of the reason why I built this wall this size is because sheathing comes in pieces that are 2 foot by 4 foot. So I just went ahead and made this easier for myself. A standard size of OSB sheathing is going to be 8 or 9 feet. That's part of the reason why that's our standard wall size.
Katie, quick question. So
Yeah.
is the bottom plate necessary when connecting two walls?
Is the bottom plate necessary? I didn't hear the last part.
When connecting two walls.
Yeah, so you always need the bottom plate. That is what's holding in the bottom of all of our studs. So if we don't have that, then we have a top plate and then just our studs that are not connected to anything in the bottom. So we always need a top and bottom, as well as the cap plate if we're going to be building multiple walls. So yes, that is necessary. Okay, so if I'm looking at my sheet of OSB, one side here has lines. The other side here, no lines. So these lines also correspond to our regular or standard, I should say, layouts, which are 16 and 24 inches. So if I don't know how well you'll be able to see this, but if I tilt this down a little bit, let me see. Okay, so you can see that this line here is directly on a stud, as well as this line over a stud. And then obviously the end of my board over here lines up with my wall. And then this is even with my top plate here. So that is a good sign that our wall is the correct size that we wanted it to be. Then I would nail this to my wall with those smaller nails, or the ones that look like this. These are the 8-penny or sheathing nails that would go into my wall. And these, you need to nail off about every 6 inches on your studs and 3 inches on the edges. Some plans call for nailing it off every foot and then 6 inches on the edges. And basically this is going to be 1, a code dependent thing, and then 2, depending on the wall. So if I'm building this and it's a 2-story house and I'm on a load bearing wall, I'm probably going to nail it really frequently. That's going to help me give that wall extra shear strength. If I'm building this on my shed, it's not really going to be holding a lot of weight. You can probably just get away with nailing it every foot, and that would be sufficient. So part of that is going to be project dependent, but basically that's why these lines are here. That's how you would nail it in. And then last thing here, if I'm looking at the end of my wall here, so this is where, let's say I've already got my cap plate here. Let's hold it down. Sweet. I've already got my cap plate here. I've already put my OSB here. When I come and put OSB on this other side, I'm going to overlap the other OSB that I just put on the front here. So this piece, if this was a full side, would overlap all of this, be even, oh, down. You were good back where you were. Yeah. Okay, so that's going to be even here with the top overlapping this, as opposed to doing it like this, which I would have a weird corner here. So overlap that all the way in order to tie those two together. And that would be your walls all built, stood up, tied together. You would be good to go at that point for framing some walls. So questions, comments, concerns?
I am amazed with how much you ran back and forth and got all that done in just like over an hour.
That was my goal.
Katie's in North Carolina, so she, well, actually, you probably get another hour of daylight, huh?
It's starting to fade a little bit, but yeah, it's nice and humid and raining.
Yeah,
Thunderstorms
perfect.
are season, so.
So, any more questions from anyone? Okay. We will send out, tomorrow, we'll send out a link to the video, along with a little PDF that Katie's put together that has a lot of the diagrams and just some general framing information to share with all of you. So thank you, Caitie. Thanks so much, Caitie. So
thanks everybody for being here. Special shout out to my video person, Michaela.
Woot, Michaela. Couldn't have done it without you, especially tonight.
Hi, everybody.
Thanks everybody for coming.
Thanks
All
for
right.
coming.
Thanks, everyone. Have a good night.
Bye,
Alrighty,
Tracy.
Tracy.
Bye-bye.